Hello everyone, my name is Akanksha Nimbaikar. In today's video, we will be talking about Lab 3 CORBA based client-server application where we perform string operations using use cases and multi-threading. This experiment is part of our distributed systems laboratory. Before we begin, I would like to take a moment to thank my amazing team members who worked with me on this project. Our team includes Suha Taran, Deepika Mindekar, and Akanksha Nimbaikar myself. Now, let's get started and understand what CORBA is and how the client-server communication works and why multi-threading is so important in this distributed system. So let's see, what is a CORBA? CORBA stands for Common Object Request Broker Architecture. It is a middleware technology that allows the programs written in different programming languages and running on different computers to communicate with each other if they were as in the same system. In simple terms, CORBA acts like a post office for a program messages. The client sends a request, like requests a string to the server through the CORBA. The server processes it and returns the answer. CORBA achieves this by using an important component called ORB, Object Request Broker. Now we know what CORBA is. Let's explore its main components. First is IDL, Interface Definition Language. It defines which method can be accessed remotely by the client. Another is ORB, that is Object Request Broker, the main component that connects the client and the server. And then stub and skeleton. This acts like translators, but the stub on the client side and the skeleton on the server side help both sides understand each other's language. Then the naming service, it works like a directory. It helps the client locate where the server object is registered on the network. So together, these components make a CORBA a powerful system for a distributed communication. So in our experiment, we are building a string processing system using a CORBA. Here the use case, the client sends a string, chooses an operation like reverse, uppercase, lowercase, or palindrome check. The server receives the string and performs the operation and sends the result back. For example, if the client sends madam with the operation, palindrome, if the server replies yes, it's a palindrome. If the operation is a reverse, it sends back the reverse string. This is a simple but clear use case helps us understand how distributed communication happens between a client and server using a code. The next step is about program flow of a CORBA application. Let's see how the program actually works step by step. The client connects to the ORB, that is Object Request Broker, and lookups the service called string processor using the name service. The client then sends the string and the operation name to the server, and the server performs that operation inside a new thread. This is a multi-threading part. Once the operation is done, the server sends the processed result back to the client. The ORB manages all the communication between the client and the server. So, CORBA makes it possible for the client server to work together even they are in different systems or written in different languages. All we need to focus is our logic. CORBA takes care of the rest. And next important concept is multi-threading concept. Now let's talk about the multi-threading concept. Normally, a server can handle one request at a time. This means if multiple clients connect at once, the others have to wait, which makes the system slow. Multi-threading fixes this problem by allowing the server to handle multiple clients simultaneously. Each client request is processed in a separate thread. Let's take a simple example. Client 1 asks to reverse the string hello and client 2 asks to check if the string madam is a palindrome. The server creates two threads, one for each client, and processes both the requests at the same time. This makes the system faster, more responsive, and much more efficient. That is why multi-threading is a crucial part of a distributed application, and it improves performance and ensures smooth user experience. So far, we have learned about what CORBA is, its components, how string processing system works, and the importance of multi-threading. Now let's move to the implementation part. In this, we have to create a project folder name. I have created a project folder name as Lab3 CORBA. In this folder, we have to create the main three files. That is the string underscore app ideal, string client.java, and string server.java. Ideal file, interface definition language file basically defines the interface. It tells CORBA that there is a method called a process string, which takes two inputs. One is a string and another one is the operation and returns the result. And another two Java files we have created. Basically, the server file implements the logic for a string operation and uses a multi-threading, and the client file sends the string and operation to the server and displays the result. Now, let's move to the practical demonstration. Open your folder Lab3 CORBA in a command prompt. In the command prompt, first compile the ideal file. using the commands. I have written the commands in a notepad for easy to understand. So just copy this command and paste over it in command prompt. This will compile the ideal file and generated all the necessary files that are stub and skeleton files needed by the code. Now I've compiled all the Java files. Let's just compile the Java file. Here is a command called compile all the Java files. Let's just copy it and paste it in the command prompt. Here is successfully all the Java files are compiled. Until now, we have completed the two steps. Then the third step is the starting the naming service, and this is a very important step. The naming service acts like a directory that helps the clients find the server object by its name. We will start it using a command. So now for starting the naming service, use this command. Just copy and paste over it in command prompt. Run the command. This runs the naming service in the background. Now the step 4 is the run the server. In a new terminal window, in a lab 3 CORBA folder location, we have to run this command to run the server, which is copy and paste over in another command prompt. By running this command, you will see this message that is string server ready and waiting. So basically, when it runs, the server registers the object name string processor with the naming service and waits for an incoming client requests. So the step 5 is the running the client program. Then in another terminal video, we will run the client using the command. Here, the command to run the client. This command is also should be run in another command prompt window. Let's just copy and paste it in another command prompt window. Here the client connects to the ORP, looks up the string processor object, and then prompts the user to enter a string. Let's just enter a string, madam. Enter an operation. Let's enter an operation palindrome. It shows the result as in palindrome. At the same time, the server terminal will show the message processing in a thread 2, which proves that the multi-threading is working. In a summary, these 5 steps: compiling the ideal file, compiling Java file, starting the naming service, running server, and running the client, completing it's the complete part of the execution of our CORBA-based multi-threaded string processing system. Thank you for listening.